So this is the particulate diagram worksheet that I'm going to go over. So first thing it says, using the equation for the reaction 2H2 plus O2 is 2H2. Now these indicate what state it's in. So these are gases. H2 is a liquid. G for gas, L for liquid. The subscripts, as I said, they tell you how many things are in one compound or element or whatever it is. So in this case, we have two hydrogens that are bonded together, right? There's two of them, and we have two of these two hydrogens. So we have two pairs of two H2 molecules, right, that are floating around, two separate ones. We have one O2, right? These are two oxygen molecules and a pair floating around, right? We only have one because the coefficient here is what we call a coefficient for the compound or element. Right, so this has a coefficient of 1, we just didn't write it in. And then we have 2H2O, so then this gives us two waters, right, where we have an oxygen, and then we have two hydrogens on each of them, right? And we have two copies of this. So the important thing to take away from this is that these hydrogens and these oxygens are in a 2-to-1 ratio, right? There are two H2s for every O2. So just keep that in mind as we move forward. So if we're looking at these, right, clearly all of these have more than 3 molecules, which is why I'm mentioning what I did before. So if we're looking at this first one, we have these H2s in black and the O2s in white, because the O2s are bigger. These are, let's see, are they in a ratio of 2-to-1, right? Yes, they are. Right, we have two H2s for every one O2, as you can see here. So the right answer is this for the reactants, right? We're trying to label these products and reactants. This one here is neither the reactant or the product, right? The reactants are elements, O2 and H2. These are compounds. And the product has two hydrogens, right? Not one, attached to the oxygen. This one, again, is neither. The compound is not correct. So this is the product, right, where they kind of, again, scaled it up by 2. So they doubled the amount of things that we had here. Right? I drew it for 1, but in this case, they drew double, right? So they had 4 H2s, 2 O2s, and then they made 4 water molecules. So this here is the product. Two, it says the equation for the reaction is 2S plus 3O2 yields 2SO3 gas. Considering a mixture of sulfur atoms and dioxygen molecules in a closed container below, for each of the following, explain why the representation is correct or incorrect. So we're looking at this. Let's see. We have 2S3O2. And we get 2SO3. So our product, right, if we're looking at this is the same ratio as this chemical equation, right? We have 2 S's, which are these things by themselves, and we have 3 O2s in the black. S is bigger than O, that's why they have drawn it like this. So S is the bigger one. This means we should get 2 SO3s out. So it should be something like that, right? Now let's check these. So A has the correct molecule, so let's come back to that, see the others. B is not correct because they haven't even bonded, right? There was no reaction that even happened. C, the molecules are correct, so let's check that later. And then D, they're also correct, right? So B just has the wrong stuff, but A, B, or A, C, and D has the right stuff. Now the problem, oops, actually, I missed it. A does not have the right stuff. A is missing a third oxygen right there. So A is also incorrect. That's the wrong product. Also, there's 3 sulfurs and we only started with 2, but you can't have more stuff than you started with. That's violates the conservation of mass. So there's too many things, too many sulfurs in this one too, in A. So C and D have the correct molecule. Right now the problem is D does not have enough. D only has 1, which means that the other sulfur and 3 oxygens just disappeared. So C is the correct answer, right? Where you have the right molar ratio of things and the right molecule. Next, it says draw your own diagram to represent the reaction equation below. I'll do H2 in black like that. So we have 3 of them, 3 individual ones. I'll do N2 in blue, nice green. My pen changed color. And then we get 2 NH3s. So I'm gonna draw these 2 nitrogens first. And it's connected to 3 hydrogens like that. And that's it. So it's the ratio of 3 to 1, and then we get 2 products coming out. That is it for this worksheet, and then I will see you again in the next one.